out different features as we saw what people engage with and what they wanted.
Good afternoon, everyone. Hopefully you had a very nice lunch. And for this session, we're going to have a little bit of fun with the Petabyte. And my name is Reza Rockney. I'm part of the Global Solution Architecture team. And I'm very lucky and privileged in that I get to spend quite a lot of time with our customers, like Qubit, where we try and apply the technology that we're externalizing to both new and old problems.
Yeah, hi, I'm Alex Olivier. I'm a product manager at Qubit, responsible for our data processing architecture and infrastructure. I'm going to be talking a bit around Qubit and how we use Google Cloud Platform to process hundreds of million events every single day from some of the largest e-commerce sites in the world.
So let's think about what a petabyte is anyway. And I'm going to age myself a little bit and talk about floppy disks. So if you try to put a petabyte onto floppy disks and then took all those floppy disks and put them one on top of each other, they would go as high as 10,000 Empire State Buildings. If you try to download it over 4G, it would take 27 years to do. And if you took every tweet that's been ever made, multiply it by 50, that will be a petabyte. What would it mean for Qubit?
So a petabyte is about how much data we collect in roughly a year from our existing customer base. So quite large.
And actually, a petabyte is also small. It's just the information in 2 micrograms of DNA. It's just 1 day's worth of YouTube information. And 200 servers, working, to be admittedly, at a fair pace, 50 entries per second, going for 3 years, would generate a petabyte of data. For Qubit?
Given it's so small, it does that quite quickly, add up quite quickly. So we are estimating by the end of next year, we're going to have around 4 or 5 petabytes worth of data in our infrastructure.
So now that we've got companies with petabytes of data and you need to do analysis, how can we actually do some queries? How can we work with this data? So one of the technologies that we use within Google to do this, and Qubit are using as well, is BigQuery. And just a little bit of background on BigQuery. So in 2002, we had more and more data to deal with, and the Google file system was born. That was released as a research paper. In 2004, we had a lot of data now. How do we process it all? Jeff Dean and co. wrote the MapReduce paper and the MapReduce APIs that are used internally in Google. By 2006, there were some analysts in Google who were getting a bit fed up with waiting for MapReduce jobs to finish so they can do their analysis. And as you know, when you're doing any kind of analysis against data, you don't just do the perfect query that gives you the answer. You'll do a query, explore the data, move again. And if you're waiting for MapReduce to do this, you end up drinking a lot of coffee. That's not so good for your health. So they built Dremel. Again, something that they released as a research paper. And actually, the way Dremel works, there's a couple of core concepts. One of them was enabled by the fact that we had the Google file system, which is now known as Colossus. And it's the separation of storage from processing. So this separation allows us to easily share data between the company. It also allows you to decouple yourself from having to think about how big is my data size going to be for this cluster. If you think about a traditional database, you have your database, you attach either local SAN, NAS disk to it, it becomes a unit. This thing then is your sizing unit. You have to then expand it to add more data, to add more processing. With Dremel, we actually have the data just being stored in Colossus. And then there is this permanently long-lived tree of execution. So this tree is thousands of machines that are waiting for a query to come. When a query comes, you get a thin slice of time on all those machines. The data is pushed through our Jupyter networks to that permanently running tree. The processing is done, and you get your query results. If you'll notice, we actually say Dremel architecture 2006 to 2015, because there was actually an update to Dremel X, which we'll talk about a little bit later into the discussion. So Dremel is critical for Google. It currently is used by around 80% of Googlers every month. We process exabytes of data, and quadrillions of rows are scanned. I've been waiting to say that on stage. The same team, the same code base for Dremel is what has been externalized as BigQuery. And this is the tool that folks like Qubit are using. It's a fully managed, zero-ops data warehouse, convenient for SQL. And if you were at the keynote, you'll recognize this. Our idea is that when an analyst wants to run a query, they should just run the query. They shouldn't have to think about sizing, disk, any of those things. They just need to be able to get the data that they want. And there's got some big fans out there. So Matthias, obviously a very, very big fan of the product. One of the best things that ever happened to him. Maybe a little bit extreme, but anyway. And to show this, I'm going to actually run a small demo. I'm going to start a small demo, actually, and then we'll show the results a little bit later on. So if I could switch over to the laptop, please. Great, thank you. So what you're seeing here is BigQuery's user interface. This is where we can run our queries from. On the left-hand side, there is the data sets. So over here, we have a retail petabyte dataset. In this dataset, there's various tables, customers, data. So these contain several terabytes and a few million rows. However, the one that we're going to work on is the sales partition table. So this table contains a few standard fields and a record field as well, which is a repeated field within BigQuery. If I go to details, it contains just over 1 petabyte of data and 1 trillion rows. This little icon over here allows me to see the size of information that's currently going to be processed by the query. So the query we're going to run is a little bit of an unusual one, but it's just to show the power. So we're going to do a select star, so select everything, and a predicate, which is going to look at finding just 1 row. So I'm going to kick that one off. That will take some time to complete. While that's going on, I'm going to also run, at the same time, a slightly more interesting query, which is more like what people will be doing. So in this query, we're going to be doing some aggregations, a group by. There's some functions being done in sort of round and sum. And also, if you notice, even though it's across the same table, it's now only going to process 31.9 terabytes of data. So the way that this works is that with Dremel, the storage structure is based on a columnar I/O storage structure. If you imagine a table with 10 columns, every column gets its own set of files. If the select statement that you're using doesn't touch all of the files, it won't bother processing them. So in this case, the files that it's touching ends up being 31.9 terabytes of that full petabyte of data. So I'm going to actually run that as well. So both these queries will be running. They'll take around 4 to 5 minutes to finish. So in the meantime, we're going to go back to our slides. And Alex is going to talk about how Qubit uses this technology.
Thank you very much, Rez. So firstly, a bit about Qubit. We're a digital experience management platform, and our goal is to put an end to these meaningless customer experiences our clients have to deal with, which end up eroding your customer relationships. And the way we do this is through data. So we transform business understanding of their customers and how they kind of influence them. And we have this kind of pipeline of how we look at the world and how we action and deliver experiences to different users. So we have data coming in from all sorts of different channels, web, mobile, app, backend systems, for example, and it lands on something called the Qubit Visitor Cloud. This is the name for our processing architecture. And this is where most of the work in Google Cloud happens. So in here, we run various different systems. First off, we run some insight analysis over the data. So we're looking for segments of users that may be under or overperforming through different parts of the site or the app. We are running ML and NLP to find out what people think about the experience. So we actually proactively ask questions. How can we improve? What do you think of this site? And we use that, and we find statements and sentiments based upon it, and then use that to trigger the next section of our pipeline, which is the actual experience management. So an experience to us could be a personalization, let's say, for a segment of customers that you consider a VIP. It's a very common thing in the e-commerce space. And you want to give these people a differentiated experience, maybe a shipping promotion, maybe getting some clutter out the way on the checkout funnel so you can get them out and purchase and kind of on with their lives. We also take an automated approach to this. So programmatic experience is a big focus for us, and we're doing things such as social proof. So if you've ever been on one of these hotel booking websites or flights, it will say 10 people are looking at this hotel at the moment. This was booked 10 minutes ago, for example. That's the kind of thing we deliver through our platform, as well as product recommendations. We do abandonment recovery, so actually personalizing the message you receive in an email, for example, when you leave the site. Here's the items in your cart. Here's maybe an offer that's relevant for you. And we push this out through the different channels the customer has, be it web, maybe a push notification, as like an email as well, or basically supporting any other channels of marketing that one of our clients has. So we do this at scale, and we have some of the largest e-commerce sites in the world running on our platform, hopefully some of which you recognize. And this actually all adds up to a whole lot of data. So at peak, on an average day, I took this number from a couple of days ago, we were doing about 100,000 messages a second through our pipeline and processing it. So we're dealing with tens of petabytes flowing through each step of our system on any given day. So how do we get here, and how do we end up using Google Cloud Platform? So a bit of a history lesson for Qubit. We've been around for about 6 years now. So go back to 2010 when we first started. We were using kind of our customers' existing data, their analytics systems, maybe some back-end transaction stores, to go through and mine and find kind of opportunities and segments where the experience may not match the expectation. We also launched a very basic tool called Opinions. So this is where the NLP and the actual feedback came in from customers. And from that, we'd come out with recommendations. So we did that for a couple of years, and this is where we kind of realized that the data we got is good, but it could be a lot better. And when it comes through delivering experiences, we need to know as much information as we can. So, if you're purchasing an address, what color it is. If you're purchasing a holiday, what destination, what seats you booked, whether the hotel got Wi-Fi. So very, very granular information, which is very relevant for building that dynamic customer profile, which we can then use to deliver a personalized experience. So we launched our first data collection system sort of back in 2012. This is back when cloud was quite early on, and things like auto-scaling didn't exist, so we had to build our own one of those. And at this stage, we were collecting data and writing it off to a storage bucket, and then dumping it into a Hadoop cluster and running kind of MapReduce jobs on top, feeling the same pain Google did with MapReduce and waiting for those jobs to finish. So we used to do this overnight, spun up thousands of servers to process the day's worth of data, but batch processing has always got latency built in. It's inherently slow. So we started working on our streaming pipeline. So in 2014, we launched our data collection system, which has been serving us well, based on a Storm. So streaming data processing, we were getting data in, we were processing it and making it available within a few hours for our analysts to go through and make recommendations to our clients. And we realized we had these massive data sets, and we could run Hive jobs on top, so using standard SQL to extract information. And we started working with BI tools, so plugging in a subset of our data into, say, a Tableau or a Looker, so clients could actually go in and explore bits of their data. So it's been great, and this has been serving us well, and we were getting data in kind of a few hours, but whenever you say, yeah, we got it down from 24 hours to 3 hours, people go, well, can you go any faster? So this is where we started working with Google, and Reds came on the scene, and probably caused him a lot of headaches. No. So we started building our platform on Google Cloud. So as of a couple of months ago, we've actually moved 100% of our production traffic, so those 100,000 events a second, over to Google. And we've actually got some sort of product offerings for free, effectively, out of it, and one is around BigQuery. So why is data important to our customers? So because we want to deliver a personalized experience to every single user on a one-to-one basis on any channel, we need to have every single data point we can collect and processed, and then push it out the other end in the form of an experience programmatically every time a user interacts with any touch point our customer has. So every data point we receive is a decision point in the tree, as it were, whether that puts someone into a VIP segment, whether that moves someone into someone that is high value but not purchased in the last 6 months. We have a whole segmentation product and system which actually dynamically puts people in and out of segments to then drive the experiences at the other end of the pipe. So our goal is to deliver real-time responses to any user action on any channel to deliver that personalized experience, and do it also at scale. So how do we do this, and how do we want to be thought of? So there's a great series, Silicon Valley, I'm sure some of you watch. There's an episode where they're talking about an appliance is so much easier to understand and comprehend. And we want to be thought of an appliance, even though we're a cloud offering. So by appliance, I don't mean a physical box in a server somewhere. We want to be thought of that way in terms of ease of data access, low latency, as if it were sitting on your desk or in your data center in your building, and also just different connections in and out in a way that's frictionless as possible for our customers. So we do something a bit weird. We've kind of operationalized GCP, so running Google Cloud as a service, as it were, for our customers. So we run and manage hundreds and hundreds of Google Cloud projects, essentially one for every one of our customers. And because of each of our customers is unique, we have to configure and set up that customer in a way based on what products or features they're using with us. So by using separate projects for every one of our customers, we can get that strong isolation, riding on the back of the Google authentication and that very solid security infrastructure, but then kind of orchestrating that at scale and pushing the right resources into that project that our client's using. So we make use of Google Groups to kind of do the permissioning and keeping things a bit sane when it comes to it. And we actually go into the market in a much stronger position than some of our competitors because of this architecture. We don't have to worry about all the complexities of running multi-tenant servers and make sure the sharding and partitioning is right. We just essentially inherit the Google Cloud setup and have orchestrated around that. So one use of this is data federation. So we do all of our processing kind of in our master environment where every single data point comes in, gets processed, validated, enriched. We go through a whole series of data flows, which we'll be going on into in a minute. And then we push out the data based on what each client's using with us. So here client A is looking at their event data. Maybe we give them a pub subtopic with all their event data in. Maybe they've got some functions running. Client B has the event data, but we have some custom workload, maybe a data proc job. And customer C is, maybe not so interested in the stream, but we can just turn on the bits that particular customer is interested in. So how does this actually help our customers, though? So we've actually turned BigQuery, as it were, into a product. So Qubit Live Tap is functionality that you can get on our platform where every client can get access to their raw event-level data inside of BigQuery. And this is possible due to the way BigQuery works with the storage and compute separated. So we can store the data centrally and then federate it out through the permissioning and the actual system that BigQuery gives you. But still, we are in the scope of the Google User Management IAM API kind of environment, so everything is secure. We have full logging and access and query logs through the cloud logging console, and things like quota limits are kind of key to making sure we keep a handle on costs as clients start using more and more of their data. So by using Google Cloud in the way we do, our customers get to take advantage of the whole ecosystem. And ecosystem is kind of a very important one for us. So we had to make a decision and to know which horse we're going to back here, which cloud platform are we going to go in and start using with our customers. And with BigQuery, it's just one part of the platform, and there's kind of the whole ecosystem of services which we're utilizing throughout our pipeline to get the data into BigQuery in the first place. So to give you an idea where we were sort of a couple of years ago, very common sort of open source projects out there, we started swapping out components. So we use Mesos for workload management. We now run everything on Kubernetes and Container Engine. Our Hive clusters are now just replaced with a BigQuery instance, so not having to run hardware in a data center somewhere to process our data and our analysts to use. If you're worrying about RAID configurations when you're running a data warehouse, something's kind of not right in 2016. Kafka goes to PubSub, so fully managed messaging queue has been great for us, and Dataflow is kind of where we had our original in with Google, as it were, to start using the data processing in the platform. So why did we go with Google Cloud? Firstly, you get the basics right. So every cloud provider has storage, compute, network, those kind of things, and that's the kind of foundational core. Just on GCP, the compute differences we see compared to where it used to be is VMs launch in number of seconds. Cloud 66 is in research. It's around 40 seconds on average to well over a minute we've seen before. And what's actually really interesting and kind of exposes how Google have exposed the compute infrastructure is the way we can do fully customizable instance types. So our application logic, we know what kind of workload profile it needs, and we know exactly how much CPU and memory it will need per instance. So we have fully tweaked and tuned and making sure we're only using the instance types we need, and therefore not throwing money down the drain. The network side of things is the interconnect between the nodes is very important when it comes to this large-scale data processing, because we're always shuffling data around and scaling up and down. So getting the bits between the machines is going to be a bottleneck eventually. So the fact that we're getting upwards of nearly 400 megabits per second per CPU on every instance we run is crucial for the kind of workloads we have. But there's the three kind of exciting bits in the ecosystem which supports our use of BigQuery. So we've got Bigtable, Dataflow, and BigQuery, which I'm going to go into a bit now. So first off, Bigtable. So in our kind of old pipeline, we used to get every single page view or an event that happened on any one of our customers, process it, and write it off to an HBase cluster. So our HBase cluster, we were having well over 1,300 regions per server, which is kind of above and beyond what you're meant to do with HBase. We had hundreds and hundreds of servers, hundreds of terabytes worth of disk in these. And things started to get a bottleneck. And also provisioning was quite hard. So we had our bare metal machines in our data centers, which were provisioned. We had our infra team making sure they're working, making sure the disks are alive, things like that. And we always had to provision for peak. So we're coming up to November, which contains Black Friday, which if any of you work in e-commerce probably know is going to be your largest traffic side of the year. And we have to handle the traffic from every single client we work on at the scale we do. So when we provision, we have to hit our peak and always provision full peak plus some. And any time you would have seen in one of these allocation graphs, any time where you have a gap, you're just throwing money down the drain, which is not going to go down well. So what we needed was a solution which allowed us to be kind of elastic in that sense, and not us having to provision the whole time for the peak, which only comes for a few minutes, as it were, throughout the day. So this is why we switched over to Bigtable. So the way Bigtable works, it again decouples the storage from compute. With our HBase cluster, we were being limited by disks, not the actual compute power, so we had to add more machines and more disks, which just take up more and more money. So Bigtable's been great because we now just write data in and then scale up the front-end nodes, as it were, to actually pull out the data at the rate we need. Migration was dead simple because we were moving over from HBase, exact same API, obviously Bigtable HBase from the same source. And things like the lookup latency is really good on Bigtable. So we actually hit HBase or Bigtable now from web scale levels of requests. So getting that response time is key because we actually make decisions based on which experience we're going to show to a particular user for any one of our clients by hitting HBase and getting some results back. So getting that latency was kind of key, and it's about 6 milliseconds. And finally, the seamless scaling. So if we want to deliver the right message to the right user at the right time, we need to be able to scale up to reach demand. And Rez is actually going to give you a bit of an example.
Thanks, Alex. So if we could go back to the laptop, please. Thank you. So these were the queries that we started. This one was the select star against the petabyte of data. That actually completed in 246 seconds. Sorry, my mental arithmetic isn't good enough to get to how many minutes that is. The other query completed a little bit longer, 400 seconds. Those were the results. We can actually now look at the explain plan as well. So as one of the new features within BigQuery, you can actually see all the stages that the query went through and the number of rows. The input rows there was reduced dramatically in that stage 1 to a much smaller number of rows as it processed the data. So that was the results of the queries that we run at the start. Alex has been talking about Bigtable and the fact that you can scale it up and down very quickly. So now I'm going to do is actually create a Bigtable cluster. And then I'm going to just scale it up for you. So here we have Google Cloud Bigtable instance. I'm going to create an instance, give it the name of next demo. That fills in some fields for me around the cluster properties and the name. I'm going to pick somewhere in the US. I'm going to start with 3 nodes. And actually, the values at the bottom, the reads and the writes. So these 3 nodes will give me 30,000 QPS at around 1K, read or write, which is about 660 meg per second of throughput. I'm going to use SSD disks because this is the disks that would give us that 6 milliseconds on the 99th percentile response time. So let me create that query. OK, cluster's done. It's in place. I'm going to use Cloud Shell, which is the ability in the browser to actually run commands to our clusters just to create a table for it. So just bear with me for a second while this connects. And we have a quick starter script that is available on our website when you use Bigtable. So I'm just going to kick that off. It will return momentarily. And the only instance that I have in existence is the next demo one. So that's the one that it's going to default to. Hopefully you guys at the back can actually see that. I'll try and make it a little bit larger. Might be better. So once that finishes, once doing that, let me just copy and paste this. Go back. OK, so I'm just going to do a list. This is the HBase command line. There's nothing there, as you would expect. It's a new cluster. I'm just going to create a table, do another list. That table now exists, the emp table. So I'm going to size this cluster up. I started with 3. 30,000 QPS isn't enough. We need to bring it up a bit. I'm just going to go into that cluster, edit it, and go from 3 to 30. So what that's going to do is give me 300,000 QPS and around 6,600 megabytes per second of throughput. Save that. That will take ages to do. No, it's done. So that's how long it takes to scale up from 30,000 to 300,000, and to go down again, obviously, just as quick. And this is what allows Qubit to be able to size everything correctly based on the throughput that they're actually seeing.
Yeah, exactly. And this is not just a throwaway demo. This is exactly the kind of thing that we do when we are scaling up and down for peak. And the fact that we've gone from having to think months in advance, get extra servers in, set them up, set up the array configurations, make sure HBase is installed, add them to the cluster, migrate the data across. I mean, it's just a lot of work. It's just one command line and cool, and that's it. And this is exactly the thing we're going to be doing as we start heading towards the Black Friday date where our peak capacity comes in.
Can we change back to the slides, please? Thank you.
So next thing I want to talk about is data flow. So there's been numerous talks today about data flow, and we saw a bit earlier. This is the kind of thing that got us hooked with Google Cloud. So we started looking at the white papers Google were producing, and a guy called Gibran's our chief architect actually went away and we started trying to build this ourselves because our our data sets are huge. We actually need to do some work on the data to make it kind of usable and actionable. And turning data into action is kind of key when you want to deliver a real-time experience for a customer. So Dataflow is this low-latency processing framework, and Google were actually kind enough to launch it as a service. So we kind of jumped on that and stopped trying to build it ourselves. So why is it really nice? This is a screenshot of one of our flows. I took this kind of last night. We're reading some data off some PubSub. You can see we're doing about 100,000 messages a second coming in. And then we're doing some work on it. So in this case, we're doing tagging the data with some information. We're windowing it by a tag. We're grouping it, and then we're streaming it actually out to BigQuery in this case. This is just one of the many, many flows we're running in our infrastructure. So why is Dataflow really nice? It's got things like watermarks. And watermarks is something that you don't really know you need until you've actually got it, and then you can live without it. The fact that we can know exactly where we are with our data processing at any moment in time, and the data comes in late, it kind of gets put into place, and that kind of thing is just handled for you. The fact that the exact same application code that our engineering team writes can be run in both batch and streaming means we have workloads where we do get batch data from customers. We need to convert it into our format and push it into our pipeline. It's the exact same code base running in our streaming pipelines as it is from our inside the batch ones. And we've attempted this ourselves. We use kind of homegrown abstractions over MapReduce, using Storm as well, which served us well for many years. But in that case, we actually had to keep the machines up and running and things like that. We also started using Lambda architectures, which kind of gets you there to a certain extent. But Dataflow kind of wraps up all the horrible edges, as it were, for trying to run streaming pipelines for you. And the fact that it is hosted but entirely proprietary. So Google were very kind to gift Dataflow to the open source community in the form of Apache Beam. So we're not actually constrained to Google for running these workloads. The exact same application code we write can be picked up and run in another runner if we so feel the need, as it were. But we're very happy with Dataflow execution. What this means is that the very highly skilled engineers I'm lucky enough to work with every day, many of which are here, actually spend their time writing our application logic and not worrying about the processing engine itself, or our infrastructure team having to worry about, has this box in this data center and this rack position got enough disk space to do this amount of work. It's just kind of completely shifted our focus. Over to Rez to talk about Dataflow in more detail.
Yeah, so with Dataflow, it's actually two technologies from Google. It's Flume Java, so MapReduce is fantastic, but the thing is, whenever you're doing anything with data, you don't just do one piece of processing with it. You'll do something, there'll be output. That output might be split into multiple other locations. You then have other data that you want to bring in. All of this means that with MapReduce, you end up writing a lot of plumbing, essentially. And we didn't want our engineers to waste time doing that, so Flume Java allows you to write your code that you want to do against the data in a series of transforms. So you just write your business logic in transforms that are being done on the data. The system then takes those transforms, creates a directed acyclic graph of computation, and figures out the best way to put all the plumbing together to make sure that that pipeline is run efficiently. The other piece, and this was a piece which got Qubit excited when we first started talking to them, was that paper around Millwheel. And Millwheel is the API internal in Google, which we use with streaming, and it's got quite a few features that help with stream processing. But the one that was particularly interesting for Qubit was watermarks, that thing that Alex was saying you don't know you need until you need it. To talk a little bit more about what a watermark is, let's think about the difference between batch and stream. So in a batch world, you have all of the data that you're going to process. And the difference between event and processing time is non-existent. So what do I mean by that? So in a stream world, when something actually happens, so someone clicks on a browser or someone clicks an application on a mobile, that's when it actually happened. However, you get to see it sometime later. And that sometime later is never static. It's never a fixed amount of time. It will ebb and flow as the data arrives. And in this graph, the 45-degree line in the middle would be if it was a static amount. So you always saw the same difference between the thing happening and you seeing it, you'd get that value. But in no system that deals with streaming do you have that line. What you do get is that ebb and flow. So you'll get some stuff arriving a little bit later, some stuff arriving smaller. And why does that matter? Why do we care about that? Well, if all you wanted to do was move data from a stream to something like BigQuery and run a query at the end of the day, then actually it wouldn't matter much. But what it does matter is the reason people do streaming as opposed to batch processing. It's you want to start doing near real-time analytics against the data. And there, it does make a big difference. To illustrate this point, we're just going to go through a couple of graphs. So The graph on the right is the one I'm going to concentrate on, and this is with a perfect watermark, and then we're going to go talk about what what Dataflow can do. So we're just going to talk about the first 4 elements, the one number 5, the number 9, the 7, and the 8. The x-axis is when something actually happened, when it happened in the real world. The y-axis is when we get to finally see it. So let's start with the number 5, and let's imagine that what we want to do here is actually sum everything that's happening in a 2-minute window. So we want to count these things as they arrive. The number 5, it happens around 30 seconds past midday. We get to see it around 5 minutes later. However, the number 9, although it happens in real time a little bit after the number 5, we get to see it much later. The number 7 falls back in line a little bit. And then number 8, again, it's an outlier. Now, if we happen to have a crystal ball and our system was able to understand everything that's happening in the world and we knew every click and every human being that was doing that, we could draw a perfect watermark and say, we will always omit the aggregation, which is absolutely correct. Now, we don't have a crystal ball. What we do have is heuristics. And this is what Dataflow does. It's got heuristics built in, and it looks at the patterns of arrival. So it notices that things arrive, for example, slightly later than normal in certain pipelines. And what it will do, as we can see on my right as I face the screen, the heuristic watermark. So it doesn't catch that 9. That 9 is too much of an outlier, but it does catch the 8. So it does a pretty good job of being able to get the correct value. And it also has mechanisms for dealing with the 9, things like late data. So you get choices as to whether you want to drop it or you still want to include it in the processing. And these are the things that actually make a big difference when you're starting to do stream processing, which is a core of what Qubit deals with.
Great, thanks. So what do we actually use our data flows for? So we've got numerous of these running in our architecture, and the main thing is reducing cardinality. So we get this pile of data coming in at the top, and we need to actually get it down into a format that's usable by our downstream systems. So we use it for things like analytics, so actually doing counts and groups and trying to pull out derived information from the raw event stream. We do metrics and calculations out of it, which then drives some of our client-facing UIs inside of our platform. Things like billing, so we can actually keep track of every operation that happens across our pipeline, and then we go through and group by a customer's usage, for example. And alerting, so anomaly detection is kind of a big area at the moment, especially with the ML piece coming out. And so we're using Dataflow to actually look for trends, and if a particular customer's data suddenly drops off a cliff and things like this, we can actually detect this and action around it. Also, the batch transformation piece is actually more important than you may think. So especially when you move into a new pipeline or a new platform from an existing system, you're going to have all this historical data that's somewhere else in another format, and we need to get it in a world that everything else now lives in. So being able to run the exact same code and basically replay the old data through it and land it through our pipeline into, be it BigQuery, Bigtable, or any other service we have, and running the exact same code base in batch form is really useful. And also the Dataflow auto-scaling, again, just saving money, not having to run the number of storm nodes, for example, that we need for our peak capacity. So what do we actually achieve through this? We currently have around less than 5 seconds end-to-end latency from an event happening on anywhere on the globe, from any of our clients' websites, to going down through every single data flow we have and landing into BigQuery or being updating a record in Bigtable. And this number is coming down, down, down as we start tweaking and optimizing and using the right types of VMs, for example, based on our workload profiles. And then finally, BigQuery. The demo you saw was, again, not just a throwaway demo. This is the kind of thing that is the reality now. And when you get to kind of petabyte scale, you're finally dealing with big data. So if you look at the data warehousing landscape, you kind of get this grid of query speed versus volume. And very small data sets, you're not really that interested in querying it fast. Just start off with a spreadsheet. That's simple. You want to go a bit more complicated. You want to start writing SQL. You've got some, still relatively small volumes, but you want faster query speeds. Jump on MySQL box, some other database system like that. We've tried pretty much all of them out there, and once you get beyond a certain threshold, things of data volume, things get kind of complicated with sharding and partitioning, and adding enough nodes to the cluster so you get enough throughput plus the amount of storage you need. And then you can maybe switch over to a Hadoop Hive type system where you get tons of data, but queries in the orders of minutes. And we kind of need something to fit the best of both worlds, which is kind of nicely where BigQuery sits. So, everyone's working on a data lake, and the single customer view is very key, big at the moment in kind of e-commerce and more generally, knowing exactly everything about your customer. But given the volumes of the web data or the app data, your data lake, you don't want to end up like a data puddle. It needs to be able to handle the vast amounts of data you've got. And we've tried pretty much everyone out there, and BigQuery's kind of filled the job for now. So why is it so good? It's that best of both worlds approach, and it's got some really nice features, such as the streaming inserts. So if you have a streaming data pipeline, but you then have to do batch loads to your data warehouse, it kind of doesn't fit the picture. So being able to stream data directly into our customer tables instead of BigQuery is a key one for us. That, again, the separation of the storage and compute is key, so we can dump more and more data in, and it's only when we need to query it we pay the cost, therefore not running big, expensive servers the whole time, just in case we want to run a query. The integration with the IAM and the federation allows us to share it with our customers, and the fact that BigQuery is always constantly improving. We've been dumping data into BigQuery now for well over a year, and over that time we've seen things such as the capacitor release, which we're going to talk about in a second. The partitioning is huge for us because we care about only certain periods of time when a user interacts with any one of our customers' touchpoints. And also the standard SQL support. So moving over from a Hadoop Hive-based house, and our analysts got very used to writing SQL, we need to kind of replicate that kind of workflow for our internal users and also our customers. So the standard SQL support is big one for us. And then the BI tool support. So we worked with Looker and Tableau and being able to give that continuity even though the data source underneath is swapped out to BigQuery. So over to Rez, talk a bit about capacitor.
Yeah. So if you recollect from the start, we had this slide around Dremel and how it looked up until 2015. So one of the changes that we have put in is Dremel X. So in the previous slide, we have this permanently running tree of execution, and it had some limitations. And what the new system does is it's got this dynamic serving tree. So previously, that tree is static. It is the shape it is. With the new dynamic tree, every query can have a different shaped tree based on what it needs to do. It can also do parallel processing of the pipeline. So a query can be taken into its constituent parts. All of those parts can run in parallel through the new Dremel X infrastructure. And also, some of the more complex queries will just run better on this kind of environment. Previously, they would have had to maybe go a couple of times through the tree. So this allows for much faster processing and more complex queries to just work. The other part, I didn't realize there was a build to this. Sorry. We talked about the columnar I/O storage structure. So this is the table with different file per column. And in the original version, we obviously are compressing the information that's stored in the columnar I/O storage structure. If you wanted to do a predicate lookup, so you're trying to filter out on a value, we would previously uncompress an entire file to actually match the symbols. However, with the capacitor build, and again, sorry, I didn't realize this had a build. I don't like builds. So with capacitor, rather than decompressing the entire file, what we do is we match the token on the filter. This leads to dramatically improved queries. So on average, we're now 2 times faster on all of the queries that are being run. Alex talked about his experience at Qubit. And on selective filters, where we're looking for that predicate, between 10 and 1,000 times faster than the previous model. And all of this was happening while everyone's in production. There's no downtime. It's a fully managed system. So over to business impact.
Thanks. So to take my engineering hat off and to put my commercial hat on in the product management role, when you look at how Google Cloud has changed the way we work and the way we built products for our clients, we've had this change of mindset. So we now have this great new toolbox with these new features coming out left, right, and center, things being upgraded transparently in the background to make everything better. And so our engineers are working in a new way of thinking. So we don't have to worry so much about have we got enough capacity, have we got the right type of Kafka set up in the data warehouse, in the data center, things like this. And we've kind of got a new hybrid approach. So through the work Google's done with Apache Beam, for example, we're not going to be fully tied in. We live in a hybrid world. A hybrid cloud is very commonplace. We have stuff kind of all over the spectrum of services out there. So we need to be able to think on how we can have a hybrid approach to everything. So Beam and things like the cloud storage sync that Google's built as well. So when it comes to the engineering efficiency, we are moving at a much, much faster velocity now. We had projects that we previously scoped of taking over 6 months, completing in 6 weeks, because we're just taking parts of the platform, taking where our data sits, gets processed, pushing it into other area of the system, doing some work, and not having to worry about the underlying ecosystem, the underlying environment, or the underlying systems. We get to just work in the application logic. For the finance side of things, our costs are much lower, not through the fact we're running less, but the fact that we have things like the sustained usage discounts. The longer you're on a VM, the cheaper it gets, which is like incredible. And also auto-scaling kind of at every part of the pipeline. So we're never going to be over capacity for the amount of data we got in and we're processing for our customers. Not having to do capacity planning this year for Black Friday and kind of these peak seasons is great. Last year, like I said, we were processing and setting up more and more servers before these peaks, which just takes time and money. So, and we've got a zero provisioning, essentially, analytics stack. So we have data coming in, going through every step of our processing step, system and making available inside of BigQuery without us having to think of a single server or a single data center. It's there and enabled, and our focus is now on the application logic, and the valuable engineering time is spent on our application logic, which then drives value for our customers. And also, we get kind of free product offerings for our customers by the fact that Google opened up some new systems. So to use an analogy from Shrek, we have the onion of Google Cloud and Qubit, where at the core of our systems, we have the compute storage network, BigQuery Dataflow, which Google provide us, and then we take those and build our APIs and services and our client-facing applications on top of it. So every time this core gets better, everything gets better for free further up the stack. And there's so many innovations coming out, and the Cloud ML release that Google have just announced is really enhancing our platform. And ML is a big focus for us now.
So obviously, no discussion of data these days is complete without mention of ML, at least at the end. And actually, the bit that's often not talked about with machine learning is that 80% of it is actually data engineering, especially when you're going to get these things into production. So there's a very complicated and very sophisticated part, which is the data science. But actually turning these things into production systems takes a lot of work. And these are the fully managed data flow, BigQuery, Bigtable. These are the tools that allow you to deal with very large data sets, which is the fuel for most machine learning, and allows you to do things like feature extraction, all of the pre-processing. Once you've got that nice model that's able to do the work, how do you build the system that takes the raw data, allows you to rebuild models every night, allows you to do the inference, allows you to do the A/B testing? These are all the things that these fully managed environments makes easy. So once the data scientists have actually built the model that's going to make a difference, it shouldn't take a huge amount of effort to actually convert that into something that's running in production for you guys. And I know Qubit is heading that direction.
Yeah, so as a real-world example, we have our data science team at the moment working on the Qubit ML platform, which will analyze all of our customer data and start finding relationships and interests of a particular user, so we can make sure the experience someone receives on site matches what we know and think about them based on their existing behavior. So it all comes down to being able to personalize at scale by using machine learning and exposing opportunities for our clients to serve on to their customers.
Great. Thank you very much. Hopefully that was useful. And if you're still interested in data and analytics, there's a session with William Van Benebe and Jaguar Lambert of Citi later on today as well. I'd strongly recommend you go and see that. Thank you.
Thanks.